In Chapter 21, we will be looking at a group of compounds referred to as carboxylic acid derivatives, and we will talk about an important reaction that they undergo, nucleophilic acyl substitution reactions. Carboxylic acid derivatives can be interconverted by nucleophilic acyl substitution reactions. And these reactions are very important both biologically, because proteins and fats are biosynthesized by nucleophilic acyl substitution reactions, but also industrially. About 3 billion pounds of nylon and 4 billion pounds of polyester are made each year by nucleophilic acyl substitution. In this chapter, we will first be looking at the carboxylic acid derivatives, some general information, properties, spectroscopy, and ways to prepare these compounds other than nucleophilic acyl substitution. And then we will focus on these reactions that interconvert the carboxylic acid derivatives, and then finally we'll talk about some other reactions. This video focuses on examples and naming carboxylic acid derivatives. So let's take a moment to review the different categories of carbonyl containing compounds. So when we have an acyl group, so the carbonyl and the R group to which it's connected, in general that is called an acyl group. If that acyl group is connected to a hydrogen or to another carbon, then we have aldehydes and ketones. And these are in their own category. But in terms of carboxylic acid derivatives, we have a carboxylic acid itself. If we have the acyl group connected to OR, so some alkyl group rather than an OH, this is an ester. If the acyl group is connected to a halogen, this is called an acyl halide, or just an acid halide. If the acyl group is connected to an oxygen and then another acyl group, this is called an anhydride. If the acyl group is connected to sulfur and then to an alkyl group, this is called a thioester. So it's just the sulfur version of an ester. And finally, if our acyl group is connected to a nitrogen, that nitrogen could be connected to hydrogens or to carbons. This is an amide or amide. There are different pronunciations. So this is the group of compounds referred to as carboxylic acid derivatives. And one way to think about it is that all of these can be hydrolyzed to give a carboxylic acid. Notice the common feature is that we have the acyl group connected to some electronegative element or a group that could potentially leave. These are not good leaving groups like we would see in a nucleophilic substitution, but it is a different type of leaving group. When it comes to naming carboxylic acid derivatives, it's helpful to think about the carboxylic acid as the base name. So this has the common name of acetic acid. Throughout this, we are going to use the acete part and get rid of the ic acid and then replace it with a name that corresponds to the particular type of compound. So this compound is an acid chloride, and in particular what we have is acetyl chloride. So instead of acetic acid, we replace the ic with YL, and then we specify which halide is present. The next compound is an anhydride, and so because these are both the same group, then we would name this as acetic anhydride. If these groups were different, then we would name them differently. So if one of them was acetate and one of them was formate, it would be acetic formic anhydride. So we name the acids and the anhydride, and we would list this alphabetically. The next compound is an ester. And so now we're going to take acetic acid and replace it with 8. And then before that, though, we specify what the alcohol part of it is. So this is methyl. So this compound is methyl acetate. Our next compound is an amide. Actually, our next 3 compounds are all amides. So again, considering acetic acid as our base name, we are going to keep the acete part, but this will be ACET and then amide. Acetamide or acetamide, different ways that you can pronounce that. But this tells you it's an amide, and this tells you that it is this particular amide. Now, this is still acetamide, but now there is a methyl group substituted on the nitrogen. So this is called N-methyl acetamide. Oops. And then the next one, notice we have 2 methyl groups, both connected to the nitrogen. So this is N-N-dimethyl acetamide. Our next compound is a thioester. So we name this similarly to what we do with the ester. So with the ester, we had methyl acetate. So this is going to be methyl thioacetate. One other group we haven't mentioned yet, this is a phosphate ester. You're going to see a lot of these in biological systems. So this is the acetyl group. So this is called acetyl phosphate. Like always, I'm not going to ask you really detailed naming, but I do want you to have the basics of naming so that if I talk about propanoyl chloride, I want you to be able to draw that structure. In a couple weeks, we'll be using methyl benzoate. I want you to be able to draw that structure. And just a little bit more about naming. So this table is in your book, and we have, for comparison, the structure as well as the name ending. So carboxylic acid ends in ic acid. For an acid halide, it will end with either YL halide or OYL halide. For the acid anhydride, this is a general structure, and you name the acid pieces and then anhydride. Amide, it is named as an amide. An ester, we have the 8 ending or O8 ending if needed. For a thioester, it has the thioate ending. And then finally for an acyl phosphate or a phosphate ester, it would end with a YL or OYL phosphate. So thinking about these general rules, let's draw some structures. So if we have ethyl acetate, well, remember this is based on acetic acid, and then ethyl is what's on the alcohol side. So this is the acetate part, and then here is the ethyl. So this is ethyl acetate. Next, we have benzoyl chloride. So that comes from benzoic acid, but from this acyl group, we now have the chloride. And then an ethyl benzamide, another one that is based on benzoic acid, but instead of having the OH, we have a nitrogen. That nitrogen is connected to one ethyl group, and it must be connected to a hydrogen as well. So get a little practice from name to structure and from structure to name.